Hello everyone. This video is in continuation with the previous video, Matter in our Surroundings, Change of State of Matter, Effect of Temperature. If you haven't seen that video, then please do check that as well. And if you like our videos, then please give a thumbs up and subscribe to our channel. In our previous video, we discussed how with the increase in temperature, solid changes its state to liquid, and on further increasing the temperature, liquid changes to a gaseous state. We learned that substances around us change state from solid on heating to liquid, liquid on heating to gaseous. But there are some that change directly from solid state to gaseous state and vice versa without changing into the liquid state. Let us discuss this with the help of an activity here. Here we have an apparatus which consists of a stand and a burner, a china dish which consists of ammonium chloride, also known as camphor, and an inverted funnel on top of the china dish with a cotton plug stuck to the end of the funnel. Now when the china dish is heated from beneath, what do we observe? We observe as the china dish containing ammonium chloride is continuously provided heat, we can see fumes of ammonium chloride vapor within the funnel. What is this process? Well, a change of state directly from solid to gas without changing into liquid is called sublimation. Here, in case of ammonium chloride is directly converted to the vapor state without undergoing the liquid state. On observing the funnel, we can also see some ammonium chloride solidified on the inner surfaces of the funnel. A direct change of gas to solid without changing into liquid is called deposition. Therefore, there are two processes, sublimation and deposition, in which solid changes to gas and gas changes to solid without changing into liquid. Previously, we discussed what was the effect of change of temperature on the states of matter. We would now discuss the effect of change of pressure. We know that difference in different states of matter is due to the difference in the distance between the constituent particles. We know that in cases of solids, the distance between constituent particles is very less as compared to liquids and gases. In liquids, the distance is still more than solids, but relatively less than gases. Gases tend to have maximum distances between constituent particles. Now, what will happen when we start putting pressure and compress a gas? Will the particles come closer? Do you think that increasing the pressure can change the state of matter? Well, let us consider a cylinder with a piston on top. By applying pressure, particles of matter can be brought closer. Here in the first case, we can see that the piston is not pushed. As we move forward, the piston is continuously pushed to apply maximum pressure to the gas. Therefore, applying pressure and reducing temperature can liquefy gases. Let us consider the case of solid carbon dioxide. Solid carbon dioxide is stored under high pressure. Solid CO2 gets converted to gaseous state on decrease of pressure to 1 atmosphere without coming into liquid state. This is why it is called dry ice. The example of solid carbon dioxide clearly tells us that by applying pressure and reducing temperature, we can liquefy gases. Thus, we can say that pressure and temperature determine the state of a substance, whether it will be solid, liquid or gas. We started off by learning the conversion of solid to liquid. When we provide specific amount of heat to solid, solid melts to form liquids, like in case while constantly providing heat to ice cubes, they eventually reach a temperature after which they change their state. Similarly, by heating the water continuously, we obtain the temperature at which liquid changes to gas. The temperature at which ice cubes melt to form liquid is known as the melting point of ice, and the temperature at which water changes its state to gaseous state is known as the boiling point. Further, we learned that how solids can directly change to gases by the process of sublimation and how gases change into solids with the process of deposition. Now we shall be discussing a very important topic, evaporation. Do we need to change pressure or heat for changing the state of matter? Water, when left uncovered, slowly changes into vapor. Wet clothes dry up. Well, is it really important to constantly provide heat or change pressure in order to obtain a change in state of matter? How do wet clothes dry up? Why does a water which is left uncovered on a surface eventually changes into vapor? What happens in these cases? Particles of matter are always moving. They are never at rest. In any state, particles possess different kinetic energies. Even in case of solids where constituent particles have very little spaces, they still vibrate about their mean positions. In case of liquids, a small fraction of particles at surface having kinetic energy are able to break away from the forces of attraction and get converted into vapor. We shall discuss this with the help of an activity. Take 5 ml of water in a test tube and keep it near window or under a fan. Take 5 ml of water in open china dish and keep it near a window or a fan. Take 5 ml of water in open china dish and keep it inside a cupboard or a shelf. Record the room temperature and time and days taken for evaporation. And repeat the above steps on a rainy day as well. After conducting the activity, our observations would indicate that rate of evaporation depends on 4 things. It depends on surface area, depends on temperature, increase in wind speed, and humidity. Now let us discuss how rate of evaporation depends on all these factors and with which factor it increases and with which factor it decreases. It increases with the increase in surface area. Well, as evaporation is a surface phenomenon, therefore as the area increases, the rate of evaporation also increases. We have observed this very commonly while trying to dry our wet clothes. We make sure that we spread all our clothes so that they dry in a small amount of time. With increase in temperature, the rate of evaporation increases. Increase in temperature, more particles get enough kinetic energy to go into vapor state. As the temperature increases, more and more particles on the surface obtain more kinetic energy, as a result of which they go into vapor state. That is, they overcome the forces of attraction between the particles and are able to change the state. Increase in wind speed. Clothes dry faster on a windy day. With increase in wind, particles of water vapor move away with wind, decreasing amount of water vapor in the surrounding, as a result of which the rate of evaporation increases. Now let us discuss how decrease in humidity increases the rate of evaporation. Humidity is nothing but the amount of water vapor present in the air. The air around us cannot hold more than a definite amount of water vapor at a given temperature. If the amount of water is already high in the air, the evaporation decreases. Therefore, lesser the water vapor present in the air, more is the rate of evaporation. With this, we come to an end of our today's video. Today we discussed the effect of pressure on the change of state of matter and the concept of evaporation, and how it increases with increase in surface area, increase in temperature, and increase in wind speed, and how decrease in humidity tends to increase the rate of evaporation. If you like our videos, then please give a thumbs up and subscribe to our channel. Thank you.